these platforms, there are specialized algorithms which are known as recommendation engines or recommendation systems. Identification or extraction of user behavior. It may be related to user browsing behavior, user clicks or views, how much time you have spent on a particular video, how many times you have clicked on a specific type of link, which type of products you are checking, you are analyzing. On different food-based platforms also, such algorithms are implemented like Zomato, Uber Eats. So we will discuss about this implementation in Python language, by which way such platforms work, by which way recommendations are performed. These are extracted from different portals. First of all, we will see what is a recommendation engine or which type of working panel is there, which type of data extraction is implemented, which type of prediction is provided by recommender system. So delivery of the most relevant information to user depending upon their browsing behavior, depending upon their historical visit on that platform. You might have seen same thing in Amazon or similar online portals where we get some particular suggestions, and it identifies our spending capacity also. Okay, for example, we are purchasing some items, we are regularly purchasing some items within a range of 5,000 to 10,000 rupees. In that case, we will get recommendation in that range only, or near to that range. It will not give me suggestion about some product that is costing 50,000 rupees or 1 lakh rupee or more than that, because recommendation engine or that algorithm works on different parameters: my spending capacity, my behavior, which are different favorite links, which type of items I am clicking, and we are rating it. And nowadays it is implemented in offline mode also. Offline mode means when we move to smart point or big bazaar or similar shopping malls or similar showrooms, you might have seen they note down your mobile number. Okay, and if you are moving to that particular location, to that store repeatedly, then you will get suggestions on your phone. So in so same thing they are performing. They check your behavior, your browsing behavior, your visiting behavior, your spending capacity, each and everything, whatever you are buying. Again, after that, what you are purchasing. It is also related with a traditional data mining approach, that is a priori. Previously, it was associated with a priori algorithm for association rule mining. But nowadays, these algorithms are integrated with high performance implementations, mathematical formulations. And you can see here type of content filtering, type of data analysis, by which way identification of pattern, by which way identification of user behavior is done. So first technique, that is collaborative filtering. It is related to books. So not only with some particular products, not only with some smartphones, it is implemented on different portals related to ebooks also. If you have ever visited Kindle bookstore, so it also gives some suggestions. Okay, if similar type of users are reading or accessing a specific book or specific literature, then using collaborative filtering means same type of users are focusing on a particular product, and in that particular scenario, that data is clubbed in cumulative way. It is identified, okay, this is the overall ranking of this particular book and it should be suggested. Similar users are reading or accessing same object, whether it is book or product or gadget. In second segment, that is content based filtering, it is related to interior components, interior parameters of that product, as well as each user. In case of collaborative filtering, group of users are analyzed, group of visitors are evaluated. Okay, for example, users or visitors of this age group, they are interested in this type of product. When a new customer or new visitor will come of same pattern, of same group, of same gender, or same type of behavior, it will be recommended to that. Collaborative filtering on the basis of age group, on the basis of earning capacity, on the basis of location. It is more localized. Collaborative filtering. In case of content based filtering, interior parameters, detailed aspects of user along with detailed aspect of product is accessed. So for example, in case of collaborative learning, collaborative filtering based recommendation, movie recommendation we can take. Same age group students or users are interested in a particular type of movie or web series, then recommendation is given to those set of users. Same approach is implemented in case of different OTT platforms. On whatever type of content we are more focused, we are provided recommendation on basis of that. And if any other user or visitor will access that platform of same behavior, of same type of pattern, then recommendation is given. Okay, so first of all, we are discussing about the base concept, by which way it is done, at back end what is the strategy. After that, we will see its demonstration part also in Python, different libraries of Python for recommendations. Other programming languages also supported, Java, PHP, .NET. In every programming language, such algorithms or implementations are available. So you can see here whether we want to work with user-based or item-based. For example, in this particular slide, you can see A, B, and C are giving 5-star rating to some particular books, and D is buying. D is some other person. That person purchased that book Y. So obviously X will be attached with that. Recommendation of X will be associated because X and Y are having similar features which are identified by some other users, other visitors, other readers, and on basis of that, recommendation is delivered. And in user-based, so A and B are interested in same movie. As soon as new movie is released, it will be recommended depending upon their previous behavior, their previous interest, previous taste. And lots of research work is possible in this particular domain. As far as ensemble learning is concerned, which we have covered in previous session, that also can be integrated with this to improve, enhance, to improve accuracy, to improve prediction level of these implementations. Are you getting this point? Is this point clear to all of you up to this? Kindly confirm. Are you understanding this particular concept, whatever we are covering here? Okay. So it's up to you whether you want to work with user-based or item-based. And now, if we focus on that segment related to ensemble learning, then you can also work with merger of both, ensembled of user and item-based. So it will become a new topic. It will become a new area of research or new segment. You can test whether it is possible or not. It may be possible, it may not be possible, but it will be identified only when it will be implemented. Okay, because every research work start with hypothetical thinking. Every research start with some assumption, with some vague ideas. And when we try to implement those vague ideas, those hypothetical things, those imaginations, then we come to know whether it is okay or not, whether it is acceptable or not. Okay. And in case of model-based collaborative filtering, so one is user-based or memory-based. You can see that this is memory-based. In memory means user-based and item-based. Why it is written memory-based? Because users' historical behavior, users' history is stored in a database. Data set is created that this person is fond of purchasing this type of item. This user is fond of watching such type of movies or web series. Memory based, item based. So likeliness or interest associated with each item is already recorded. It is memory based. As far as model based is concerned, we go for deep analysis of product as well as object. Object means object may be user. Deep analysis of user behavior, user profile, not only behavior, user's profile also. And matrix factorization, model based methods which are focusing on matrix factorization. It is more accurate. If we are having a huge data set, large data set, millions of records, if you will identify a data set of a particular shopping mall, if you are having a large data set of Amazon, Snapdeal, Ola, Uber, then we will be having a huge matrix, huge data set. And traditional data science methods can't be implemented on that without pre-processing. If we are having large data set like Amazon, Netflix, YouTube, we have to work with matrix factorization. Matrix factorization means decomposition, fragmentation. That is also known as making the data easier for analysis. Okay, so if huge data set is available, millions of records, thousands of attributes, we have to make it simple. We have to normalize it. In technical way, we can call it, we can relate it with normalization, or one concept you might have studied that is known as principal component analysis, dimensionality reduction. Because in large data set, in huge data set, it is very important to work with dimensionality reduction to reduce the dimension of a data set without losing features of that specific data. Keeping all features of data, we have to reduce dimensionality. PCA is one of that, principal component analysis. But here, we do not use PCA. In model-based collaborative filtering or in matrix factorization-based approach, we work with SVD, single valued decomposition. We will see that part also. And at the back end of these algorithms, these approaches, we are having linear algebra. We have to work with matrix fragmentation, matrix decomposition, data mining techniques, machine learning techniques, data pre-processing, missing value evaluation, or null value treatment. On multiple dimensions, we have to work. Okay, so it depends on that scenario whether we want to work with model-based filtering or content-based filtering. In case of content-based filtering, we take metadata. Metadata means interior attributes. If we are discussing about a data set related to movies or web series, then what about its genre? Genre means type, whether it is a comic or drama or adventure. Which type of movie or web series is this? Producer, actor, musician. That is content based. What is the content? Okay, if a particular web series or movie is having a specific type of actor, producer, genre, musician, okay, so that is recorded at backend, and on basis of that, it is recommended to other users who are interested in such type of attributes. Whosoever is interested in uh, adventure movies or horror movies related to specific producer or director, it is recommended to that or suggested to that. Content based filtering. Music recommendations. If you are, I think many of you might be using the apps like Ghana.com. Ghana app is available, and so many platforms available, OTT based, Hotstar, Netflix. So depending upon your historical behavior, your content favoritism, episodes or series are suggested to you. So up to this point, we have discussed about different types of recommendation engines, collaborative filtering, model based, matrix factorization, content based. In model based, we have to work with mathematical part. In content based, we do not work with mathematics, we do not work with metrics, we work with only attributes and their interior aspects, whether it is yes or no, enabled or disabled, which type of person is associated. Are you getting this point? Up to this point, is it clear to all of you? Kindly confirm in chat. Kindly confirm up to this point. Is it clear to all participants? Whatever we have discussed so far in conceptual way. Now we will come to the implementation part. We will see by which way we can work with recommendation engines on different data sets. Movie lens data set, very popular data set. There are so many data sets available. Movie lens, it is related to a repository of different movies, their genre, their records, favoritism points. Netflix data is also available on internet, so you can take that also. Netflix data, Hotstar data, YouTube data set is also available. Now we will see this particular data set, and on this we will implement recommendation algorithms. On grouplens.org, this data set is available. Movie lens, different variants of data sets available. Okay, so movie ratings, 25 MB data is available. This is 250 MB data, and you can see here different variants available. If you want to take this much data, 5 MB data, it is available, or this is small data. So different variants of data sets we can take. If you want to work with wiki lens data, that is also available. So for collaborative recommendation engine, Jester. So more than 4 million ratings of jokes. Okay, so which type of rating is done by 4 million users? Okay, and this data I have already downloaded. I'm showing you that this is the data set. Okay, multiple variants of data sets available, which we have already downloaded. So you can see that movies.dat. Is it visible to all of you? This data set of movies, movie lens data. So you can see that in which year this movie was released, and type of movie, comedy, drama, fantasy, adventure, and this is ratings.dat. What is the rating and users? Okay, so age group. In this particular file, you can see the attributes M and F for, so you can see that this F for female 1, 18, 25, 35. So you can see that this is the age group. Okay, so 56 means occupation, which are different occupations, different genres of movies, under which category these movies are: comedy, crime, documentary, drama, fantasy. And how many records? Around 4,000 movies, and ratings more than 10 lakh anonymous ratings. Is this visible to all of you? More than 10 lakh ratings, anonymous ratings, or anonymous reviews related to this much movies. Okay, and for this data we have already downloaded, and you can see that this is another data set. Okay, movie titles. So all of these files will be available on this portal group lens, and from that you can identify. Okay, this is Excel sheet, CSV file, movie ID and titles. And this is TSV. Now we will see by which way we can work with collaborative filtering based recommendation engine. I'm opening Spider. So you can see that. Okay, so I'm pointing it in this way so that I can read your messages also, because I will have to run code in parallel. We will see the code, source code, and along with that, we will keep on executing the scripts. Is this visible to all of you? This Spider we have opened, Spider IDE, in which we will execute the code. Okay, so this is Spider IDE, Anaconda already installed. First of all, we have to use pandas package, because whatever file we want to access, we have to read it in form of data frame. Import pandas as PD, column names in that TSV file, user ID, item ID, rating, and timestamp. At which timestamp, which user ID has given rating to which item ID. Item ID means movie ID. What is path? So I'm opening this particular, opening these files on desktop, and in parallel we will execute it. So you can see that this is the data, this is the code snippet. First of all, we are accessing that file .tsv for tab separated values. Okay, and df head. These are column names. User ID, item ID, rating, which rating is given to which item and at which timestamp. This timestamp can be converted to actual date also. Okay, there are so many functions available, cloud-based services available for conversion of timestamp, Unix timestamp epoch to current date. And in same way, we will read this particular file, that is movie ID. Okay, so I'm specifying it in this way so that one by one we can execute it. So two files we have accessed here, and first is related to user ID, item ID, rating, and timestamp. Second, with movie details. What is item ID of this movie? What is item ID of this particular movie? So we have imported it in Python. And you can see here, we can merge, or we can say that we have to merge the data frames. Okay, so one data frame is this. This is first data frame related to user ID, item ID. So we have to perform a join. So in database, you might have worked on join operation. Okay, so we have to join on item ID. Join operation. This is movie details with user details. pd.merge, previous data frame is merged with movie titles, and you can associate it with foreign key. In SQL, in database, there is a concept foreign key, and on this key we can merge two tables. Okay, so now you can see that two tables we can merge. This is first frame, this is second frame, and these are merged with this pd.merge pandas on basis of item ID, that is foreign key. And group by, so that we can perform grouping. Data.group by on basis of title and rating. Title of movie with its rating, you can see here, and we have to sort it in descending order so that we can check which movies are on top. Okay, so one by one we will see this snippet, this execution, how to identify recommendations. But before that, we have to go for some basic statistical operations, including correlation based analysis. So group by on basis of title, this title. So all instances will be clubbed, will be merged with their average ranking. Average ranking means, average rating means title, their rating, mean operation, sort value. So you can see that. If I'm not using this add, then complete will be displayed, okay, in this way. So these are top movies, and these are least popular movies. Is it visible to all of you? If you are using .head, so only top records will be visible. So with this head, only top records, and if we have removed, then this particular output will be generated. Okay. To this point, are you getting? Kindly confirm by which way we are performing this implementation, by which way we are merging the data sets, we are merging frames for further analysis. Up to this point, are you getting whatever we are covering here? In chat, kindly confirm. So if we see next part, so up to now what we have done, so this is first segment, second data, join operation, and mean rating of movies. And with mean rating, we can count also, we can check total rating also. So here we have used dot count, and previously it is dot mean. Okay. So You can see that count total ratings. This, so highest number of ratings with these movies, and we are removing this. Then, so ascending through, if we want to see it in ascending order, so this is in ascending order. False. Descending order. And then creating data frames, creation of data frame. So you can see here, group by title means, so we will create data frame of ratings and count values. In this way, we will get the output. Ratings, total number of ratings. This actually our motive is to find out similar movies. If I want to see, okay, which are similar movies like this, which are movies similar to this movie, which are recommendations, which movies are in recommendation or will be in recommendation, who will watch this movie. If somebody is liking, if somebody is interested in this particular movie, then which other movie that person can see, that person can subscribe. So our motive is to identify that part. Evaluation of similar movies depending upon their historical ratings, their previous number of ratings. So from 9 ratings, what is the average rating? From 109 ratings, in this way. Okay, we can plot these graphs also in this way for ratings. Okay, now for generation of recommendations, we have to work with pivot table. In data science, pivot table is very important for data analytics. In almost every implementation related to data analytics, we have to we have to work with pivot tables. Whether you are working in traditional MS Excel or Python or Power BI or Tabula, whatever tool you are using, this is most effective tool or that implementation used in analytics part, including recommendations. So we have to create a data pivot table. So this pivot table on which point, on which index, user ID, rating. Our main focus is rating. Column will be in title. Okay, so here this in this way. Movie mat. In this way. And after that, this is the main point of recommendation. For recommendation evaluation, this is the most important point. Analysis of correlations. Correlation value. Because if we want to generate similar movies like X, then we have to find out correlation between X and other data set. If I want to see similar movies or similar products like A, then we have to calculate, we have to analyze correlation. What is correlation of A with other movies or products? So what is movie mat? Movie mat is the, you can see this is the pivot table. So we compare this pivot table with individual rating. Okay, with individual ratings. So this movie mat, this is your pivot table, and with this pivot table, we check existence of a product or movie name. So this code, this presentation, I will share to all of you at end of the session so that one by one you can explore. Okay, so you can see in same way, if you want to go for this user rating dot head. Okay, so you can say this is the correlation value. Correlation of this with other, with the entire pivot table. In this way. And then we see movies similar to this correlation dot correlation with. So you can see that analyzing correlation